Good morning, we are going to solve exercise 335 from the book Fundamentals of Electrical Circuits Sadiku. This exercise tells me that it repeats problem 3.5. Applying tie analysis. And if we look at problem 3.5 that I have here, it tells me obtain V sub 0 in the circuit of figure 354. Well, now this 3.5 exercise was using knots. Now we must do it using loop analysis or mesh analysis, as some call it. Well, then we have to make two meshes, one called mesh 1 and the other called mesh 2. And well, when you do mesh analysis, what we practically do is an analysis of voltages in a loop to find current. When we do knot analysis, we did current analysis and found voltage. Here we do voltage analysis to find current. Let's remember that when we did knot analysis, they were voltages over resistances. That was current, but in the end the equations are in terms of voltage and we find the voltages because we use the LCK principle, loop analysis. We do this analysis of voltages, which is current through resistance, and when doing the equation, since it will be in terms of current, we end up finding those currents. Okay, so let's make mesh 1. What is this A practice that many of us do is that we take the current clockwise to the right. Then they could also take it in another direction. It is also valid, but this is for practice. I'm not going to go into the analysis of mesh 1 and I'm going to start here. It would be 2 kiloohms times mesh current 1. So I say it's 2 ca. I'm going to omit the UFO, right? To not do. Well, since we are doing a circuit analysis, we already know that this is obvious, right? The resistors so as not to have to make the symbol because I always have a little difficulty with this board, and at the same time we save time and space. So 2K times the current and 1. This is the voltage. Here resistance times current is voltage minus. Yes, because I'm taking this meaning minus 30 volts EH. There are some that take this voltage as output. Let me explain. If the current and when I say goes clockwise, this would be polarizing more or less. That is why more is put in by the current and then less comes because it is entering. I'm looking at where the current comes in. There are some who take it going out, so I would take this, it would be less, and here it would be going out, it would be more. So, 2 kilometers down the current and 1 minus 30 volts. Look over here. Further. 20 volts. If as it is a LVK, it is the voltage. Here the voltage, here the voltage, here and the voltage here. More since we are doing mesh analysis 1. We can say that current 1 is greater than current 2. Then it would be 55K, which multiplies the current and 1 minus the current and 2 equals 0. Applying algebra, I have 2K equal 2 and I'm going to put everything that has the current variable. A single side equals 2K times the Y1 plus 5K. For the N1 also minus 5K for the N2 and 1 minus N2, and this would be minus 30. Plus 20 would be minus 10. On the other side of the equal would be 10, so 2 plus 5 would be 7K. Well, I'm going to put it here below. 7 kilometers of the current and 1 if this K, remember that it represents that the current is 7,000 and 1 minus 5K of the current and 2 equals 10. So equation 1 We are going to make the mesh 2 loop 2. Now K would be 5K. Now since I'm doing mesh 2, I'm saying that the current 2 is greater than the 1 equal to the Y2 minus the Y1 minus 20 volts plus a 4. 4 for the current and 2. This, gentlemen, is B if it is 0 because it is current through resistance. It gives me the voltage drop here, which they are marking here is 0, which is what we need for the moment. Let's take it into account equal to 0 and algebra 5K the N2 minus 5K of the N1 up plus 4K. Everything is in K that I need to put the K what penalty of the N2 equal to 20, so it would be minus 5K. Of the N1, of the N2 I have 5 plus 4 2 plus 9K of the N2 equals 20. I have my equation 2. Okay. Let's use MATLAB 7. We are going to put here 7 space minus 5 semicolon minus 5 space 9. And the equal would be 10 semicolons and 20. Well, the space after the semicolon is necessary. I put it here and it tells me that, hey, it's 5 and 5. Well, here I was wrong about something. Well, it's not that I'm wrong because, well, one understands here. But let's remember that this is in K in terms of K, so here it would be 5 milliamps. This is in milliamps to be more exact. Well, I can put here that 7,000, that 5,000, 5,000 again 9,000, oh yes. And just observe so that you can be careful with that. It is the same, but here in milliamps 0.005. I multiply it by 1001, 23, it would give 5,000 amps. So the current in 1. Be careful with that. The current in 2 is equal to 5 milliamps. No. Or 0.005 or 50 is 12,305 amps. Be careful with that. Many times they sin by not including what K is worth. So what about the voltage here? Well, we said that it was 4 times the N2. The N2 times 4 times is 0 is equal to a 4K 4,000 times the N2, which is 5 milliamps. K with milliamps, so it cancels out. So I wanted 5 times 4, 20 volts, and this is the exercise 3.5. You can check the 3.5 video and they will realize that it doesn't matter to us exactly. See you in the next exercise.